Welcome to video 4.4b, more on the equidistant theorem. All right, so here's the theorem itself. If 2 points are equidistant to the endpoints of a segment, like we showed before, then the line connecting those 2 points forms the perpendicular bisector of the segment. Okay? I'm going to allow you guys to use a picture for this, so I'll put it above here. Instead of writing down all those words, I allow my students to do this. If that's the perpendicular distance thing, then perpendicular bisector. So again, if we've got these 2 points that are equidistant, then those 2 points form the perpendicular bisector. And I'll show you how I use that in the proofs. Okay, so we've got a couple examples here. Example 1. Given that angles 1 and 2 are congruent and 3 and 4 are congruent, prove that AE is the perpendicular bisector of BD. So you want to make sure you know who's bisecting who. So AE perpendicular bisector of BD. All right, so what I really want to do is if I could get points that are equidistant, I'd be good to go. So that's kind of my game plan whenever I see these kinds of problems. All right, so let's mark up the diagram. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Oh, we had a theorem before that said if I've got a triangle and angles are congruent, then their opposite sides are congruent. If I've got a triangle with angles congruent, then their opposite sides are congruent. So what you want to look at is the top triangle as an isosceles triangle, and the bottom triangle as an isosceles triangle. And then you'll see the proof immediately. All right, so let me write it down. So step 1, angle 1 congruent to angle 2, given. I'm not going to write down all of my givens. From that flows these equidistant points. So I'll now say AB is congruent to AD if angle thing, then side thing. And what I'm going to do is I'm going to put a little point there. Whenever I've got to use the equidistant theorem, I need 2 points. So that's justification for 1 point. Then angle 3 is congruent to angle 4. That was given. And then in that bottom isosceles triangle, I could say BC is congruent to DC. Again, if those angles are congruent, then those sides are congruent. So if angles, then sides. I will put a point there. Again, when I'm grading your quizzes and tests, it's really easy if you do that for the grader, which is me. Then, once I've got those 2 points, I can use the equidistance theorem. So now I'll say, what do they want me to say? AE perpendicular bisector of BD, and I'll show you how I'll let you use the shortcut. We'll say if, and I call that kite thing because it looks like a kite. So if kite thing, which is those equidistant points, then perpendicular bisector. Okay, we'll try another example. For this example, I kind of gave you the given, the prove, and the diagram in the problem and asked you to do that, but I'm just applying it for you right here. All right. So given isosceles triangle ABC with base BC, so that means that these sides are congruent, these angles are congruent. D is the midpoint of BC. Prove AD is perpendicular to BC. Again, I'm looking for 2 points that are equidistant. So that's what my brain is thinking. I'm going to mark up the diagram. So I've got this congruent to that. Oh, point A is equidistant to those endpoints. D is the midpoint. Point D is equidistant. So when I've got point A being equidistant and D being equidistant, then I know I've got a perpendicular bisector. Okay, it's going to be the same kind of proof. So statement. All right, so I'll say isosceles triangle ABC with base BC given. From that, I'm going to go to those sides. I don't care about angles, I care about those sides. So I'm going to say AB is congruent to AC if isosceles triangle, then basically I've got two congruent sides. So note, point A is equidistant to those endpoints. Now let's see if I can get point D. D is midpoint of BC. That was given. Definition of midpoint, two congruent segments. So BD is congruent to CD if midpoint, then two congruent segments. So now that point is equidistant, and I've got my 2 points. So the line connecting points A and D, which is segment AD if you want to call it. So AD, perpendicular bisector of BC. And once again, if kite thing, then perpendicular bisector thing. And we'll do a couple more examples, and hopefully this will be a clear lesson for you.